I'm Alicia Davis. Hi. And Sleepio is a new app that has just been approved by NICE, recommended by NICE in May 2022 this year. It's a web-based self-management program based on its elements of cognitive behavioral therapy, or CBT, involved in it to help to manage sleep problems and insomnia. There was a number of studies that clinical evidence review within NICE worked through. Actually, there's about 12 randomized control studies looking at Sleepio compared to medications for insomnia, and find that Sleepio was more effective actually at reducing insomnia than sleep hygiene and medication or sleeping pills. So now that new app web-based program is available, has been approved by the NHS, by NICE, sorry. There is a cost of £45 per person to access it, and people have access, I think it's for up to 6 months. And but it will be, I'm sure, up to local health funders to whether there's capacity to fund that locally or not. But just to let you know about that one.
Great. Next up.
Fantastic. Oh yeah, so Decide AI. So there have been a number of reporting guidelines that have either been published or are in the process of sort of probably final stages now of being written up. But one that I wanted to flag was Decide AI, which was published, I can't remember, about a month, maybe just over a month ago, which is reporting guidelines for early feasibility studies, so early stage evaluation of AI studies. And it has a particular focus on human factors and human-computer interaction evaluations, and it sort of advocates for these small-scale early stage studies before you launch into a full-blown sort of clinical trial. And the really nice thing is that although it's a reporting guideline, obviously we don't have many of these types of studies at the moment, and it's not necessarily the standard thing to do these small-scale pilot studies. So it actually goes into quite a lot of detail about sort of the methodology that you would apply and where we can learn from other human factors studies. So that was co-published in the BMJ and Nature Medicine, and was led by someone called Baptiste Fazy, who we will hopefully be able to get onto one of these special interest groups at some point once we fix the date. So I played a very, very small part in the steering committee of this as well. It's really enjoyable, and there's lots of other amazing people who worked on this. But yeah, that's Decide AI.
Brilliant, thanks Al. And finally, in the inaugural headlines section, just drawing attention to the fact that next month is going to be the publication date of NICE guidelines for artificial intelligence software to help clinical decision making in stroke. So this focuses in on the different kinds of brain scans, CTs in particular, and they're looking to see not only whether it can help with the diagnosis of stroke, but also whether it can help with the decision-making process, which surrounds thrombectomy, so mechanically removing the clot in the case of ischemic stroke, but also thrombolysis. And so it's looking particularly at the use of CT scans in decision-making with regarding to that process, whether for thrombolysis, CT scans and the use of this AI software is clinically and cost effective. And then there are two secondary aims of the guideline. One is to look at CT angiography and AI and its role in decision making for thrombectomy, and also CT perfusion scans and their role in the decision making process around thrombectomy. So an exciting development in the field. So next we're going to move on to a primer One of the things that I realised when I first moved into this area and became interested in clinical AI is that there is a lot of jargon, and there are a lot of terms that are used that I didn't understand to begin with. And because we want this to be a group that can literally take people from no knowledge through to understanding, and take them on a kind of pathway of education, and education is one of the key aims of the interest group as it stands. We thought that we'd start in this session by just going through a few of the key terms and demystifying them. So this is going to maybe at quite a basic level, but I think that everyone, at the very least, will find it helpful, and I'll try and throw in a few historical elements to spice it up a little as well. So, a glossary of terms for clinical AI. So, one of the first things that's a little bit tricky in this area is when someone said the word algorithm to me initially, I thought of an image a little bit like this: a lot of mathematical terms and symbols that were impossible to understand. But actually, an algorithm in its simplest form is simply a list of instructions. And this is an example of an algorithm here of actions that are to be taken in the case that you've got a lamp that doesn't work. First, you're to check whether the lamp is plugged in, then you're to check if the bulb isn't working, and it gives you instructions that to follow based on those points as you discover them. And that is exactly what's happening in an algorithm in AI or deep learning. It's simply taking an input and giving an output. And yes, the list of instructions that it follows may be very long and complicated, but in its simplest form, it is just following a list of instructions. The next term is model. So there's lots of talk about statistical models, but what exactly does that mean? Well, a model is simply a relationship between two variables, and I'd just like to highlight at this point a guy called Josh Starmer, who has a YouTube channel called StatQuest, which is absolutely brilliant for breaking down lots of different elements of statistics, and moves into areas of machine learning as well. And his explanations are really brilliant. He also plays the guitar and sometimes sings songs just to jazz it up a little. But his example when he's talking about models is to refer to mouse size and mouse weight. And you can see that as mouse weight increases, mouse size also increases. And if you've got that relationship mapped out on a graph, as we can see there, you can fit an equation to describe or to summarize that relationship. And in this case, it uses a linear equation, which basically means that there is a line that is trying to approximate the relationship that is seen between mouse size and mouse weight. And because you've got that equation, you can then try to predict what a mouse's weight would be based on its size, and also vice versa. So that's algorithms, models, and equations. But what about machine learning? Well, you can see that we're already now equipped with some terms to help understand this definition, which is actually just from a dictionary, but is a good definition. And if we just highlight some of the important elements of machine learning from this definition, it's to do with computer systems that are able to learn and adapt, but particularly without following explicit instructions. So it's not as if there are lines and lines of code saying exactly what the computer's meant to do in different situations. There's some kind of learning element to it. It uses algorithms, which, as we've just discussed, are a set of instructions, and models, which are the relationship between two different variables, to analyze and draw inferences from data. And different data points. And there are a few main types of machine learning, and the ones that we're going to talk about today are supervised, unsupervised, and reinforcement. So if we start with supervised machine learning, now the key here is that you have labels. and that you start with a labeled data set. That's also known as a training data set because it's what's used to train up the model, to train the algorithm so that it can then make predictions based on it. So in this case, we have a data set of 3 different types of shape: hexagons, triangles, and squared. And in the labeled data set, all of those shapes as they appear as images are labeled with the ground truth of whether it's a hexagon, triangle, or square. And once the model is sufficiently trained, and there are various ways that you can statistically see how well trained a model is, you can then take unlabeled data, known as the testing data set, and show, simply in this case, images of the shapes, and ask the model to predict the label based on the appearance of the shape. Now, in a clinical context, such as rheumatology, in which it is my area of interest and my area of clinical work, we've used this in particular cases with these quite specialized types of scans, which take 100 very fine slices at the distal radius and also at the distal tibia. And then those images, those slices, can be reconstructed 3-dimensionally and give such an intricate image of bone. It's actually known as a virtual bone biopsy. And these are labeled for those people who are fractured and not fractured, and that's what's used to train the model using the training data set. And then we've shown separate, unlabeled 3-dimensional images of the bone to the model and asked it to predict whether that was associated with a fracture phenotype or someone who hadn't fractured. So that's to give it a bit of clinical context. Unsupervised learning is mainly to do with spotting patterns that are within data. So this can be through clustering, for example, in which different parameters and similar types of, for example, patients in a patient group are clustered together according to appearances in a data set or particular characteristics within a data set. But the important thing is that it doesn't have the same associated labeling as you can see in supervised. And finally, reinforcement learning. So this is one that's fairly rich with jargon because you start with an agent and an environment. And again, it sounds like jargon, but a good example of this is described is for example with self-driving cars. So the agent is the self-driving car, and the agent has a goal within an environment. So the environment in this case would be the roads along which the self-driving car might drive, and the environment can inflict different states onto the agent, onto the car. So that could be a pedestrian walking in front of it, or different weather conditions, or varying levels of traffic. The agent then senses those changes in state of the environment around them, so through movement sensors, for example, to sense pedestrians, or for example, sensors that measure the amount of water that's falling onto the windscreen to measure how whether there's rain or changes in weather, and takes actions based on that. So it might swerve to avoid a pedestrian, or if it has access to a map and can see levels of traffic, it might take measures to avoid it. The environment then gives particular rewards to the agent based on the goals. So let's say that the goal of this car was to travel home from the Alan Turing Institute, which is based next to King's Cross and Euston in North London. The closer that the car gets to its home, the greater the level of the reward. And so it learns to take more and more efficient routes. And this is thought to be probably the best approximation to the way that humans learn. Well, how does machine learning fit in the kind of grander vision of artificial intelligence? And we've got a picture of Alan Turing here. So artificial intelligence is really the grand vision. And yes, machine learning and the computer systems, the self-learning element, sit within that. But artificial intelligence is this grand vision, and for intelligent machines. And this was described by Turing in one of his seminal papers in 1950 called Computing Machinery Intelligence, in which he described something called the Turing test, in which there is a tester, here labelled C, who then provides the same test to both a machine, A, and a human, B. And the test in this case is that if the machine performs to the same level as the human, it is derived as having a human level of intelligence. And we can think of many examples now that might fit that Turing test. And there we see that within that overarching umbrella of artificial intelligence, we have machine learning and also deep learning, which is another element of machine learning that we can talk about at another one of these meetings. But essentially, the takeaway point is that artificial intelligence is the overarching concept of these intelligent machines. And there is, within the field, there's this concept which I first heard introduced by actually Alan Turing's nephew giving a talk about the history of his uncle, called the robot fallacy. So Alan Turing was obviously well known for his work that was made famous by Enigma and Benedict Cumberbatch. Following the war, he then moved to work at the National Physical Laboratory and actually worked directly underneath a guy called Sir Charles Darwin, who was the grandson of the Charles Darwin. And at that point, the National Physical Laboratory was trying to predict, I think it was missile trajectories. So they were trying to develop statistical models that could predict where a missile might hit once it was fired. And apparently Turing found this relatively boring and decided that he wanted to take a sabbatical. So he went away for a year, and the reason I've got the photograph there is he was actually a very keen and very good runner as well. He went away and wrote a paper called Intelligent Machinery that was about developing mathematical models for brain circuitry, and came back and presented this to his colleagues at the National Physical Laboratory, who absolutely ridiculed it and described it as no more than a schoolboy's essay. And when they were talking about it, and I think it even got into the press, they said that Turing would infect the countryside with robots. And it's at this point that his idea, his concept of intelligent machinery was first aligned with robots, and this image that we see here of artificial intelligence being synonymous with a robot. But that's not necessarily the case. Artificial intelligence could exist in any form. It doesn't have to be obviously associated with a robot. And Turing's nephew draws this out to say that people say that the realms, it has this kind of science fiction association with artificial intelligence, whereas actually it is really rooted in really robust mathematics. Anyway, so there's a little bit of history for you. The next thing I just wanted to mention is that the area of computer vision. So when I first heard about this, I thought it was, I could see that computers were able to label images, but how on earth they got there, I had no idea. And one of my colleagues in the School of Electronics and Computer Science at Southampton really helped me to understand this by thinking about what is it that the computer actually sees. So, as I said before, I'm a rheumatologist and work a lot in osteoporosis, so here we have a bone, rather fittingly. But of course, what the computer doesn't see isn't necessarily a bone, but sees a matrix of pixels that in this case are both black and white, in some other cases they may be grayscale. But it doesn't even necessarily see pixelated bone, it sees a digital bone in which those black and white squares are assigned numbers of intensity, so 0 for black and 1 for white. And if we see that image, that bone, as a mathematical matrix, we can then see how that can be subjected to complex statistical analyses, because you can take one matrix and you can multiply it by another. So ultimately, you have a series of numbers, and that is how computer vision techniques are derived. And next, we have area under the curve. So this is an output that you will see often in machine learning papers, particularly those to do with diagnoses. And it is the receiver operating characteristic curve, and was originally devised by analysts looking at radar, again in the Second World War. And you plot the true positive rate, which is the sensitivity, against the false positive rate, which is 1 minus the specificity. And the key is to look at the area under the curve. So if the area under the curve is, as you can see here, is as is seen by the dotted line, that means that 50% of the area under the curve is 50%. And if that's the case, then the classifier or diagnostic algorithm that you produced is actually no better than tossing a coin, because it means that 50%, you might as well toss it and say, well, if it's heads, then there's a diagnosis, and if it's tails, then there's not a diagnosis. But as that number, that area under the curve, moves closer and closer to 1, then the diagnostic performance improves, until if it was 100% or if it was 1.0, then the diagnostic performance would be perfect. I haven't seen that, but in theory, that's where we get to. So that's just highlighting a few of the terms that we come across, and in clinical AI, some of the interest areas, and I don't know whether we want to open up a discussion now briefly, or move onto the parlement.
Thank you so much, Nick. That was really good. Yeah, I think we should maybe open up for a few minutes. I certainly found a lot of these, and still find a lot of these concepts really confusing, and often revisit. You think you understand it, and then often revisit it and learn something new and realize I never understood it at all. Does anybody have any questions or inputs, or any experience with any of this?
I was just going to say that I think that one of the ground rules that we really want to encourage within the interest group is that often the best question is a basic question, and just to open up questions from whatever level that people have them. So feel free, but if not, we can always move on to the Parliament, and then
we have some hands up. So we've got a physical hand up from Hugh, and then we've got a virtual hand up from Sandy. So let's go to Hugh first.
Yeah, thanks very much indeed. And hello, everyone. And I'm sorry I can't raise my hand. I can't find the tool on the Zoom I've got online. Just a point.
Just out of interest, where are you? Just so
I've already put it in the chat. I'm a jobbing doctor on the South Coast. Curiously, I was one of the kind of people who did the input to decide, sort of as an external inputter of responding to the questionnaire, Decide AI. And I'm also the non-executive director of one of the new ICBs, so I'm quite interested in where the rubber hits the road in terms of the theory of AI versus clinical application at population level. That's really where I'm interested. But I just wanted to go back to your algorithm plot there, because it was a cute little diagram that has lamp doesn't work, plug in, change bulb, buy new lamp. And of course, it's missing the step of check fuse.
Yes.
In a way, I think that is a brilliant analogy of one of the fundamental problems with it. Now, with the whole of this data thing, and we don't need to get into it now, but bias / ethics also interests me. If you like, that is the perfect example of the wrong action or the wrong next action in an algorithm. And of course, if you put that early in the algorithm, you skew the whole output, and that has huge implications for clinical application. So I just thought I'd make some mischief and say that.
No, that's a really, really good point. That's a really good point, and also highlights the important area of ethics and bias, which we're certainly going to include in later sessions as well. Thanks, Hugh. Out of interest, where on the South Coast are you calling from?
Sorry, I'm at Hastings at the moment, but I'm on the Kenton Medway integrated care system. But I'm in the Conquest Hospital in Hastings.
Oh, brilliant. Lovely to meet you.
Thanks. You too.
Sandy, hello.
Hi there. Yeah, so I'm Sandy. I'm an anaesthetist and intensivist. I actually also work at Southampton, Nick.
Great.
And I'm doing a PhD with down here, looking at sort of prediction of patient-centric outcomes after major surgery. But I suppose my question is not so much a question for you guys, but for the wider group. It's having listened to you do those terms, that was really interesting and really helpful. But looking at the background of a lot of people in the group, there are a lot of people that come from a mathematics, statistics, computer science background who may well know the machine learning bits back to front. And I'd be interested to hear from them. Do they think they would benefit from a primer on any clinical aspect? And are there bits of clinical research that to them they go, I have no idea why they all get so het up about this? And would there be benefit to a clinician giving a sort of a primer on clinical research for the mathematicians and computer scientists?
Sandy, that is an excellent suggestion. And one of the things that for example, one of the things that I thought about in this is what exactly is clinical? How do you define clinical? And of course, it's it could be related to why not medical, and it could be due to the difference between the fact that we study medicine and surgery at medical school, or is clinical just more broad? But I totally agree. Well, Sandy, were you volunteering to
I'm not sure I was, but I think equally, I think that the real thing we need to find out is what are the bits that people find confusing, because obviously you and I are kind of underqualified to say, oh, this is probably the difficult bit. What would be really great is for somebody from another background, I'd happily work with somebody if they kind of went, oh yeah, I've got some really clear ideas and they want some feedback. Obviously I'm happy to contribute kind of thing, but I think it's a really interesting one to get a feel from a group of what they'd like to learn about from a clinical perspective.
Absolutely. Brilliant. Yeah, well, maybe we could draw that out in the Jamboards later.
And just in the interest of kind of sharing and pooling, and hopefully one day we'll get to be able to do this really, really organically, and maybe hopefully even in person, is Sandy, I know there's somebody in the room who has very similar interests to you, who's just knows exactly who I'm talking about. So Joe, do you want to jump in and maybe share what you're working on, because I'm sure you and Sandy will have stuff to talk about as well.
Great, thanks, Sharon. Sandy, I was actually just halfway through writing a message to you on Zoom, so I'll delete all that. So Sandy, I'm Joe. I'm a anaesthetic and intensive care reg. I'm working with Zhao, other members of the Birmingham team. We've got a few different hats, one of which is the Standing Together project, which is a project which will look to improve the diversity and transparency of data sets in healthcare. But my PhD is looking at perioperative risk scores, in particular their validity in intersectional and disparate population groups. So it'd be great to find out what you're up to and any areas of mutual collaboration, perhaps.
Yeah, absolutely. I will drop my email address in the chat and just send me a little email, and we can start a conversation from there. That'd be great.
Amazing.
Love it.
Fantastic. I was being opportunistic there.
Yeah.
Right. So shall we move on to the Jonathan, go for it.
Just to add in there, up until last year, I was a practicing breast radiologist in Portsmouth. So we're heavily on the south coast here today, aren't we? And what occurs to me listening to that discussion between you, the three of you, is what clinical means is going to have a sort of service, a heavy service element to it. Because I know working breast screening still from the AI industry side, the narrative is different when we're talking about ground truthing and we're talking about adoption and all sorts of regulatory issues. The narrative is different between different clinical services. So I'm sort of nervously offering support to that activity as well.
Brilliant. Oh, that's great. It's nice to have some Queen Alexandra alumni as well in the room.
Ah, yes, got the medal.
Okay. Brilliant.
There's a few comments in the chat as well about generally just perhaps data sets might be an interesting topic to revisit in the future. Yes, and sorry, Vignesh, you've got to put your hand up.
Yeah, no, I think one of the other, so my background's pretty much in everything data and like clinical trial stuff. So I think one other thing that's really interesting, along with like a primer for the kind of terminology around AI, is kind of expectation around it, which I think is really interesting, because I think often the kind of standard, it's kind of held against the perfect standard, whereas humans are held against a different standard. And that kind of understanding, especially around consistency and variability in humans versus AI, which I think is a really interesting thing. Because I think primers are really useful in terms of getting context, but I think a useful part of that context is the expectation setting around that.
Yeah. Here. Where are you calling from, Vignesh?
At home. I'm actually not working at the moment. I know Jonathan just spoke. I was at Chiron Medical up until last year, so I sadly didn't get a chance to work with him. But I left last year, and I'm actually currently in the process of looking for roles. But yeah, just
Oh, brilliant. Fantastic. Awesome. Lovely to meet you.
And Sandy?
Sorry, me again. It was just another topic that I've been thinking about as I've been writing stuff up for my PhD that I don't know if we've talked about, but I think has massive significance for any of us who are working in clinical data science. And that would be having a little chat about the Goldacre review and what the direction of data science in sort of healthcare looks like, how we can make that trusted, safe, secure, but also efficient and reproducible. I mean, I don't know if for people that haven't read it, it's actually, for someone who's interested in the field, it's a super uplifting and interesting document, but I think it's got massive bearings on all of our workflows in the future.
Brilliant. Yeah, definitely. Is maybe you could put a link to it in the chat.
Yeah, sure thing. I'll throw it up.
That'd be awesome.
I think that's a great idea. And if we've got people, if we have health data scientists as well, in the group, then that would be a fantastic one to maybe do a sort of, a section on.
Brilliant. Should we move on to the
Let's do the Jamboard. So right, I've just popped a link in the chat, which will take you across to a Jamboard. And this is just a way that we like to try and capture some of this stuff on little post-it notes. And so if you want to open the Jamboard up, we've got a number of questions that we'd like to ask you and get some things written down. Can I just check, is that kind of opening up all right for people? Yeah, okay, fab. So our first question to you is, thank you, person who drew a 6, is now counting things. What is your ask of the special interest group? What would you like, what would you like us to collectively organize for ourselves? And also, what is your offer? And I think particularly for the offer aspect, if it is a specific offer, then perhaps pop your name on the post-it so we know to come back to you. And that can be a variety of things. It could be running a session, it could be help organizing, it could be, giving a talk on a topic or hosting a panel discussion. It could be talking about the Goldacre review, anything like that. So we'll leave you to have a think about that for a minute. And Nick, I know whilst people are kind of thinking about this and writing, we had a few sort of things that we wanted to let people know about. Do you want to do that now, or should we?
Yeah, for sure. I just wanted to leave. What I might do is just stop sharing, and then I can always pick it up in a moment. There you go. Just so I can go onto the Jamboard. So one of the key elements of the 3 parts that we have to the interest group at the moment, it's kind of nascence, which are educating, so basically improving the education of clinicians and improving confidence with artificial intelligence. We had some brilliant talks from the guys at NHSX last week, last month, Annabelle and Mike, about their most recent report on clinician confidence in AI, and they're moving on to write a second report, which is essentially looking at how best to improve the educational level, and that's one of the things that we really want to do as well. So there's clinical AI educational activities, and anyone else who's interested in those, we're looking at potentially running a course later this year, or maybe even in early 2023, to basically address that need. Because if AI is truly to enter the clinical workplace, if it is going to be robustly used, then clinicians not only need to understand it well enough just to know about it themselves, but they need to understand how to convey that understanding to patients, so that they can tell the patients how their decisions are being informed by this piece of technology. And so anyone who's interested in that in particular, do get in touch. Then there are then there's also the pooling element. So we want to be a pool of people from the healthcare space, from various different backgrounds, almost as many different diverse backgrounds as we possibly can, to be able to feed into the health programme and the activities that are going on at the Alan Turing Institute. So, for example, there are various key collaborations between the Turing and different industry partners, and one of those, and I think Alicia, I'm right in saying the only one that's with a pharmaceutical company is with Roche, and there's something called the Turing Roche Knowledge Sharing Series, where colleagues from both those different institutions share talks in different areas, but also there is a obviously Roche have got a lot of data, and I think, Alicia, am I right in saying that they bought a company called Gridiron or something like that? Is that right?
Oh, I'm not sure about that, Nate, but I'll pop a little link in the chat on the Turing Roche partnership and the purposes of it. But yeah, you're quite right. They're really interested in how to use more data science and AI approaches to extract the value out of the health data that they own and hold through clinical trial, but with a clear purpose on improving patient outcomes in the end. So an end goal of that. And they had a call for funding it's about 6 months ago now, that had a particular focus on missingness in data and how you overcome missingness and what approaches to do with that, and kind of best practice in that. And there will be others as they come out, and that's something we can share through this network as well too.
Key that I think they've just appointed some postdocs at the Turing, I think, who are working particularly in that area of missingness within the Roche data set. So, obviously they've got huge amounts of clinical trial data, and they're very keen to know the kind of distribution of clinicians in this group, and certainly if anyone is interested and calls come out, then we'll certainly make that known. Then there's another group called the Turing Commons, and so they're very keen to produce various educational materials using different case studies that can then be applied for education, both within a completely lay context, but also with people who have got more of a data science area of expertise and people who have got more of a clinical area of expertise. So we're going to have a guy called Christopher Burr, who's based at the Turing, who will come talk to us more about that and about ways to get involved at one of our next meetings. And also we've had contact as well from some colleagues at Northumbria University who have got a Turing Network Development Award and are keen to collaborate with the group as well. So that's in the very early stages, but we'll keep you updated as we go. Alicia Zhao, is there anything else that the headlines?
I have one small headline, but I think what we could do is maybe move on to the next Jamboard. You can people can still add to this one. You just kind of go back a frame, but at the top of the page, you should be able to go on to. So there's 3 in total. If you go into the second one, what we would like to sort of get a rough idea of is people's understanding, both in the technical field, but also in clinical. And the most sophisticated way we could think to do this was to create small post-it notes, and you can essentially just drag yours along a scale from, within AI methods, from never heard of it, what is that, to I am a literal sentient robot. And on the clinical side, knowing almost nothing clinical, to world expert in my health area. And whilst that's happening, I will just plug one small thing which happened yesterday, which might be of interest, is the MHRA have released a new report on the future regulation of medical devices. So this is not, I'm just popping the link in the chat now. A lot of people might have seen this already. This is not specific to AI, but does include software as a medical device, and within that, some findings about AI. So they did a big public consultation recently. And this is, I think, taken quite a while to assimilate the absolute volumes of feedback that they got. And there's some quite interesting bits in there about the regulation of AI generally. It's quite interesting. And in fact, whilst we're here, I'm just going to also paste in a sort of a short summary by someone called Hugh Harvey, who's a ex-radiologist who now runs a consultancy firm called Hardy Health, and is often quite active on Twitter, but is super knowledgeable about regulation of AI, and he gives the sort of little thread of highlights there of the MHRA report. So if you can't be bothered to read the whole document, which is probably about 70 pages long, that summarizes the highlights for you. Wow, someone said they're a literal sentient robot. I want to meet that person. That is quite creepy. Okay, now there's 2. That's brilliant. And then at your leisure, you can move on to the third.
So just to jump in, it's really interesting for that second slide. There's actually a lovely not split, but it's not. Yeah, and some people, I'm sure, might have put a post-it in. Oh no, you won't have put. Well, depends where you're most comfortable in your space. But anyway, what I mean is we've got some lovely AI, machine learning, data science minds, and some clinical minds, which might or not might not be the same person, but that nice breadth across a spectrum, I think is really key. I was just having a look as well on the first slide. I've tried to group things into different topics, but I can come back to that in a minute. So with a couple of those themes.
Brilliant.
So there is a third slide, although there may be some overlap, I realize, with the first one, which was what your interests are in clinical / AI / both. And again, this is just to kind of get an idea of the breadth of interests and expertise that we have in the room, and also to give us some ideas to ask for future talks or future topics and things like that. There's a request on who wrote Heart-Brain Axis. Make yourself known. Someone's popped in the chat. It's me. So there we go. This is a bit like some sort of dating show where we're all in a room together and we've got to match up something.
Yes, speed dating. through a Jamboard. I'm quite impressed that some people managed to turn. I didn't turn their smiles the right way around. They rotated the post-it note. Yeah, there we go. Yeah, someone just successfully did that. Did you manage to do that, Zao?
No, but I'm going to try now.
Mine was sideways.
I'm also quite intrigued by the big pink post-it with a pic. I'm not sure what it is.
Yeah, with some hieroglyphics.
Yeah, that's
nice.
cool.
Yeah, I mean, I think it's meant to be an eye and a nose and another eye in brackets. Do you see that?
Yeah, kind of. I'm worried I'm being culturally insensitive and it's actually a language. We'll never know. It could be the sentient robot among us. The topic of a future session.
Oh, Sergey has decoded it
Oh.
in the chat. Amazing.
Very good. My goodness, maybe we should have a session on how to do that.
Icebreaker. Should we run through what we've got on that first slide now?
Yeah.
Yeah, just some of the areas. Well, Nick and Zao and I'll take this away and help to use it to really formulate what the program's going to look like going forwards. And also just to let you know, I know that some people have been trying to get on the SharePoint site and other things. We're also looking at other platforms to help to build the community, because we're conscious we don't have a platform yet, but we will do that. On that first slide, there's different groups. There's a group of post-its that are more about the data, so data ownership, data sharing, what do we do with commercial data, and all of those elements. And some lovely offers, so from Vignesh on what makes good data in clinical trials, and also Ting on neonatal data as well, and sharing some of that. So hopefully we can join up those different components. So a chunk on data, a chunk on deployment, so provider solutions and how to look at that system level as well. And Hugh, so you'll note there about some real world examples in the system. So that's great. Another one on workforce and components in that strand, about how you bring clinical AI, I suppose, into the NHS system. And then a few on national, ethical and regulatory guidance or challenges and how we can inform policy collectively. And then very lastly, one on national opportunities or new opportunities and collaborative opportunities as well too. Lots on sharing and connecting, which is just fantastic as well.
It's really cool. Very, very cool group. And the other thing that I noticed is we've got a nice mixture of clinicians, well, everyone generally that works in different sectors as well. So I think we could have some really interesting conversations about that too in the future. Now, right at the beginning, we've got 6 minutes left. Right at the beginning, we mentioned that we're going to save some time for people if they want to come and do a 3-minute introduction, tell us a bit more about what they're working on. And we've kind of done that a little bit as we've gone along, but is there anybody in the group who'd like to just say a quick hi and tell us a bit about what you're working on? No, it's okay if not.
I can mention one of my current projects that centers around AI. No one else had something. I'll keep it short to give space for.
Do you just want to say briefly what your name is and where you come from and your area of interest?
Yeah, my name is Frederick Olsen. I'm an anesthesiologist and critical care doctor in Gothenburg. I've just recently come home from a postdoc year in the United States at Wake Forest in North Carolina, and there we are working on a commercially available AI algorithm called the Hypotension Prediction Index from Edward Life Science, which is the study that we are doing is not AI, but it is using the AI tool that Edwards has developed and kind of implementing it and seeing if not the mathematics of it can translate to real world patient-centered outcomes in a strict clinical setting where we use it in one study in cardiac surgery and looking at meaningful patient outcome parameters, and another multi-center study where we use it in major surgery. And the basis of this is that the AI algorithm is a kind of image recognition, but also numbers of the arterial waveform tracing, and it sees something in that visual signal and the parameters of that we as clinicians can't see, and it translates this into a risk of a future hypotensive event if no intervention is done.
Oh,
so it kind of looks into the future, which is very exciting. But we need to move this from and it's FDA approved and everything, but we need to prove that it actually matters for patients.
Amazing. Oh, thank you so much for sharing, Frederick. Alicia, is this going to ruthlessly cut off at 2 p.m?
I think so.
Okay.
I'm not sure. Is Patty still there?
In which case, I might just thank you so much, Frederick. That's a really nice. That's a kind of taster of some things that you're up to, and that's really interesting. I know that we've got some hands up. I just wanted to make sure that everyone knew the date for the next meeting, which is Tuesday. We're going to take a break over the summer, and Tuesday, the 13th of September at 6 p.m. That's going to be 6 p.m. UK time. That will still be British summer time at that point, won't it? But Tuesday, the 13th of September. I just wanted to make sure you had that date in case we do get ruthlessly cut off. But yes, Alicia.
Oh, I don't think it was me next, was it?
Oh no, sorry. That's fine. Great. I can see hands up. Should we just carry on going? And if we do get cut off, we get cut off. Gabriella, hi. Lovely to meet you.
Hi everyone, very lovely to meet you. So I am a mathematician, statistician from Liverpool John Moore University, and now I also work in machine learning and deep learning. And my experience is I work in developing artificial intelligence solutions for detection of eye diseases. But being from Liverpool, I also started looking into developing automated algorithms to track the well-being of football players.
Okay, fascinating. Yeah. Which team do you support? Are you red or blue?
I know I must be one of them. Yes, it's red.
Ah, very good, very good. I mean,
I'm not sure if my answer was the right one, but it is the right one.
They have had a good season. A good season. Not as good as it could have been, but still a pretty good season. Brilliant. Zhao, anything else you wanted to say before we close?
No, thank you everyone for joining and making this a really fun session.
Brilliant. And we'll be in touch with any developments over the summer, but we'll see you at the next meeting, which is Tuesday, the 13th of September at 6 p.m. Brilliant. Thank you so much.
Thanks.
Okay,
bye everyone.
bye-bye. Bye.
Have a great rest of the day.
Thanks, you too.